Welcome back to First Time Programmer. This is FTP5 collaborating with Git, and this is PageKey Tech. I'm Steve. So let's talk about Git. Git, we saw in the last tutorial, is helpful for keeping track of your code and making sure that you don't lose progress. However, Git is really everywhere. It kind of underlies so many different things in the software world, and it's basically all around us. If you look, let's look at a screen share and I'll show you what I mean. If you haven't already, consider joining the PageKey Tech Discord, where you can discuss projects and ideas, ask questions, and meet fellow people interested in tech and programming. So yeah, Git's everywhere. You can look around on GitHub and find thousands and thousands of projects. One of the biggest ones is obviously the Linux kernel, which is at github.com/torvalds/linux, and you can see it here. So Linux runs everywhere. It's on your phone, it's on servers that are running in the cloud, it's on embedded devices like your Raspberry Pi. It's basically, this is the core software for so many things in our world. Obviously, not all of them. There's a lot of Windows and other proprietary things and like that. But this is such a huge open source project, and the source code for it is right here. You can actually build Linux from scratch, and I have a few articles on how you can build your own Linux kernel locally. I guess I'll leave a link to that. It's old articles that I wrote, but it's all in Git. What's another cool thing? You can actually Google Discord GitHub. So like, pick a company, write GitHub after their name. They probably have a GitHub where they share code. Now, is Discord an open source product? No, to my knowledge it's not. It's closed source, and they want to protect that code. However, that doesn't mean that they don't share bits and pieces of code and products that they write internally that they want to share with the world. It's kind of like an open source culture thing where they want to give back. And they, in this case, Discord has 233 repositories of code, 233 Git repositories that you can look at and see what's going on with it. And I don't know what any of this stuff is, but it's pretty cool. So I don't know. Pick a company, type in GitHub after their name, and see what they're sharing. Maybe there's something out there, maybe there's not. But that's basically the big idea of Git is everywhere on the internet. Now, as opposed to some other version control systems, Git is technically decentralized. A lot of times it's centralized in the way it's used, as we'll see later, but technically it's completely decentralized as a piece of software. You can push it, you can pull it to multiple remote sources, and it's fine. And you have to just manage it, merge it when things go wrong, but you can have a Git repository stored as many different places as you want, and you can push and pull between those different repositories, whether it's on a server, on your computer, or what have you. Okay, so in the last video, we had dots representing individual commits or snapshots of your code. In this video, it's going to be a little bit different. We're taking a step back where we had our commit graph and branches and things. We're just going to have one dot be that entire Git repository. All of the commits, all the branches, that's all this one little dot here, right? So we did git init, we have our Git repository, that's this guy. In this video, we are pushing that to a remote GitHub, so we'll call this GitHub, and we're sharing code. So I use git push to push my code to GitHub, so that's one direction. We don't necessarily need the arrow back yet, we're just publishing the code to the internet, right? And now people can go on their browser, open up GitHub and see it if it's shared, if it's public. Say there's a second person working on this project. They are going to clone what is on GitHub onto their computer. Now they have the exact same set of files on their computer. They have an exact copy of that repository. It's now local to their computer, so they can use it to run files on their computer. All that stuff. They can do their development. This guy over here wants to work on a feature. He creates a branch, he makes some commits, he pushes them to GitHub, it shows up here, and then I'm like, okay, I want to check out what you're doing, I want to see what you've done so far. I'll do a pull, git pull, and it ends up on my local computer again. So now I can see exactly what he did, exactly what he typed in when he committed. It looks like I typed it. It's on my computer, it's the exact same set of files. So this is centralized, right? You can add as many developers as you want, cloning your code, doing things and pushing code back. So yeah, it's looking pretty centralized, right? However, what if this is the Linux kernel and all of a sudden somebody says, oh, I want to do this radically differently. I want to make my own variant of Linux, the kernel, whatever. You can fork it. So I'm going to fork this repository to a different repository on GitHub. So this can be Linux, this can be Linux 2. And this is going to be radically different. I have totally different ideas about where I'm taking the Linux 2 project. So I can do that over here, and now I can clone this separately on my computer as the Linux 2 project, do all kinds of crazy stuff. I don't even have to ask the Linux guys if I want to merge it, because now I own the fork that is Linux 2. So I can push back and forth to this guy, and that's fine. You can also do a pull request or merge request from, first of all, that can work in between branches in a single repository. But if I do some stuff in Linux 2 and I'm like, hey guys, this is awesome, which is very unlikely, but if somehow I do something in Linux 2, me and my friends, we're all contributing to this code, right? And we come up with something fantastic. We can submit a pull request to take our Linux 2 code back into Linux. So they're going to see a pull request, exactly what's different, and they can merge it in if they want. So merging and merge conflicts. We saw in the last one how if you work on a branch, which individual developers tend to, if they're developing a feature, fixing a bug, whatever they're doing, they don't work off the main branch or the master branch. They're going to go grab their own branch, name it whatever they want, and do their work there. And then the goal is to, once they're finished with their work, merge that into the main branch or the master branch, which can be tagged as whatever and released, right? So if you have 5 different people working on 5 different features, they all get their own little sandbox branch to work on. When they're each done, as they finish, whoever is the maintainer or the software lead for that repository reviews their code and merges it in, helps them resolve any merge conflicts, and that's just the flow for development. So Git has auto merge, and typically it can handle all of these things itself, merge things in by itself, but occasionally you hit a merge conflict that Git cannot resolve on its own. This usually happens when 2 developers modify the same file, even the same line, typically the same file, Git can negotiate even that. But if they're modifying the same line, Git doesn't know what to do, it creates a merge conflict and you have to resolve it by hand. We'll see that a little bit later in the demonstration. So what are you actually typing on the terminal? Actual collaboration commands for Git. Git merge, merge a different branch into the one that you're currently on. Git push, Git pull, push and pull code from a remote repository. Git fetch, actually, if you look at Git pull and Git push, these are combination commands that say, number 1, fetch the information from the remote repo and merge it. So I usually in my day-to-day use push and pull. I think most people do, but you have to keep in mind that they're a little dangerous because you're saying go to the remote server and instantly merge it. Maybe you just want to check out what's out there, see it without merging it. That's what Git fetch is for. It goes, asks, hey, what new branches are there? What's it looking like on the remote, on the server? Then from there you can decide what you want to do. So in practice, how do people collaborate with code? Do they push it to, you know, Dropbox or something, or are they putting it on Google Drive? No, they're not doing that. GitHub and GitLab are massive for sharing code. You've probably seen at least one of these, probably seen GitHub, but GitLab is big too. I really like GitLab, it's my favorite. Both of them hold Git repositories. That's their main purpose. You push a Git repository to GitHub or GitLab to make it available to other people. In this way, it becomes somewhat centralized until you think about, well, you can actually have multiple GitLab repos for the same code base. There's forking, there's all that stuff. So what you need to know about these 2 websites is they are websites you can log in and make an account, and they make it very easy to collaborate in teams on code. So GitHub is a Microsoft product now. It's very popular with open source. So any open source projects typically go on GitHub. It's very much like a social thing where you're encouraged to explore on GitHub and see what's out there. Whereas GitLab is a pretty popular business solution. Another one that's popular with businesses is Bitbucket. Both of those are typically closed source projects, and they have a lot of tools for coordinating work on a team in a business. That being said, you can host public repositories on GitLab as well. It's just not geared towards the open source community where people are looking around, seeing what's interesting out there. It's clearly not their focus. Whereas GitHub really wants to have that social atmosphere. GitLab is more focused on what is the process, how are we getting things done. And yeah, so those are two big options. There's also Bitbucket. There are plenty of others, I'm sure, but those are the two big ones in my mind for hosting your code. So let's look at a live demo of using Git in the ways that we just described. We are going to create a GitLab account, add an SSH key. Both of these steps seem unnecessary, but there's a lot of ways that you can get tripped up doing them. So I figured I'd go through those. The SSH key is technically optional. You can just use HTTPS to push and pull code. And I guess that works, but usually you end up logging in a bunch of times. There's probably a way around that too. But I just like to use the SSH keys because you do it once, you never have to log in again. You're good to go. Push and pull code as much as you want. So yeah, we'll create a GitLab account. We will go put the code that we have in our Git repository from the previous video onto GitLab. We'll create an issue and merge request, and we will see an example of a merge conflict, hopefully, all kinds of stuff like that. So let's get into the demo. So the first thing we'll do is create our GitLab account. So go to gitlab.com, in the top right, hit register, and fill in your information. So I'll go for a little Code and Johnny. I'll just use the PageKey email, and I'm not a robot. Hit register. So are you following along? Do that. Hit register, and then you have to check your email and verify. So I'll go do that now. You click the link in your email, it's going to tell you it's been successfully confirmed, and then it's going to let you log in. So you type in your password. I'd like to be remembered, so sign in. And here we are. It's asking you select a role. Coden. It's my first name, Coden. Software developer. I want to learn the basics of Git. That fits what we're doing right now. Who will be using it? Just me for now. And what would you like to do? Create a project, join a project. For you, hit create a project. Email updates, up to you. I don't want those. So we're going to have to create, and we're going to give it a group name. Give it whatever group name you want. I'm going to say Code and Johnny. Project name, we're going to call this FTP5, and uncheck the getting started README because we already have an existing Git repo, so we don't want them creating their own commits on this. We just want a blank project. Hit create project, and now it's going to try to pull us through their walkthrough tutorial. This only happens once, and I'm going to kind of skip it. It's up to you if you want to try to follow it. And you can invite people. We're not doing that. Learn GitLab. We're not doing that. Just click on your project name up here, FTP5. Now before we can do anything, we have to add an SSH key to the account. So we'll hit add SSH key, and it's expecting us to paste a key. Where are we going to get that from? Well, open up a terminal. On Linux, just a regular terminal. On Windows, you'll probably want to use PowerShell for this. And start out by doing ls home/.ssh ~/.ssh, and it will list that folder. You should see something like this: idrasa, idrasa.pub. idrasa is your private key. Never show this to anyone. That is your identity right there. The public key you can show to people, and we will show to GitLab to identify ourselves and say, okay, this is us. Now, when we're using our private key, we can prove that it's us, and they can use the public key to see that it's us, right? So if you combine the public and the private key, you get, it's like a key and a lock. So we hold the key that says it's us, and they're holding something that says, well, if it's you, then show me, basically. If you don't have that file, this is only if you don't have that file, do ssh-keygen, and you can hit enter for all of these. Enter, 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 enter. You'll get these two files. Okay, so once you've ssh keygen, now we can cat your public key. So cat home/.ssh/idrasa.pub. Make sure it's the .pub one. Hit enter, and you get something looking like this. I'm going to copy that, paste it into GitLab, fills in the title for you, and then hit add key. And we're good to go. We have a key added. Now go back to GitLab, hit the logo in the top, and click on the FTP5 folder that we created. Now we can use some of these instructions to link our local repo from the previous tutorial to this project and push our code to the server. Okay, so now cd to the code repository that we created before, and we're going to follow the steps for push an existing repository. So right, I've already cd'd to the existing repo. Now there is no existing origin. We don't have to worry about renaming it like it has here. We're just going to copy this first line, copy, paste, git remote origin add, git at gitlab.com, blah, blah, blah. It'll be different for you. Make sure you copy it from the page. And then we have 2 steps that we have to do to push everything to the server. So we will do git push -u origin all. It did it. And then we'll do tags, even though we don't have any tags yet, but still good practice. Now, if you go to GitLab, refresh the page, and you will see you have our Git repository, both commits, 1 branch, no tags. It's all online, accessible for someone else to see. So that's a good start. Now, what's the process for working with other people in a repo? If we have 5 or 6 people working on this code base, how does it work? Well, you're going to want to go to Issues, say New Issue, and say, for example, we want to add an About page. So we're going to say Add About Page is the issue. And the description is we need an About page. Someone please do it. I'm going to assign it to myself because I'm going to work it right away. Hit Create Issue. For GitLab, this is their flow. GitHub, it's a little different, but it's very similar. So if you have the issue created describing what needs to be done, click Create Merge Request, and it's going to create a branch for you in Git called 1-add about page. It's going to create this merge request where you can, describe some things. I like to check squash commits, so it's up to you, but I do that because it keeps it clean, keeps the history for the Git nice and clean. Hit Create Merge Request. And okay, we've done our setup in Git. Now, GitLab created that branch for us. So we can say git fetch, and it detected that there's a new branch. Now, currently, git branch is master. We don't want to be committing code to master basically ever if you can avoid it, except for very small projects. You can do that, it's fine. So do git checkout 1-add about page, and we will check out that branch that we just created specifically for this issue. And now if you do git branch, we're no longer on master, we are on add about page. If you do git log, it's the exact same log that we had before. So it's basically, we're starting at the same place as master, but we're going to add some commits to do something new. So I'm going to do this as simply as possible. I'm going to say vi about.html and add a very simple page. So there's our about page. Let's save the file, and we're going to do git status, git add all, git status again, git commit, add about page. So we just made a commit to add the about page. We can push it, git push. Now go to GitLab and refresh it. Our merge request will now show that we have 1 change, and it was to add the about.html page. We can also see our commits here, add about page, which I just did. So this could be ready to go. Say we're done. Say that's it. That's all we have to do. You can add more commits, but for this one, we're done. Go up to the top, mark as ready. So note that it's a draft. You're never going to get something merged if it's a draft. Once you're done, mark it as ready. And all that does is remove draft from the title. And now we can click merge if we want. But let's simulate if there was a change on the master branch that causes a merge conflict. Before we do that, let's change our hats, right? Developer hat off, team lead hat on. Your team lead is going to come in and say, okay, let's look at what Code and Johnny let's look at what Code and Johnny did for us here. He's going to look at the pages, look at the changes, and say, okay, this looks good. Or might go in here and say, this is dumb, please change it. Add comment. And then I'm going to go in and look and say, hey, that's not very nice, but that's okay, I can change it. So we'll go into about.html and we'll say, this page is not all about us. And then we can do git commit -a is a shortcut if you didn't add or delete any files to do just existing files. And I'll say update about page per review. Save that, push it, and we have another commit out there. 2 commits. The changes are now exactly what we just saw. And we can go in here and say resolve thread because we addressed the comments. And I'm going to say approve for this because it's ready to go. Approve. And we're good to go. So now we really can hit merge and it'll merge into master. But for the purposes of this video, let's make something go wrong for this. So let's create a separate issue. And we are going to say some unrelated feature. And yeah, and I'm going to assign this to myself too. So this is where two people are working an issue at the same time, right? We're both working on the same code base. I'm going to create a merge request and git fetch again. And this could even be you working on two things at once, and you can switch as much as you'd like. So we are on branch 2 now, which just came from master as well. If you do an ls, we do not have an about.md or an about page that we just created. We only have these 2 commits from master. What I'm going to do is touch unrelated feature.html. I'll vi it. I'll say, hello, this is unrelated. I misspelled that, but whatever. I'm also going to touch about.html. Remember, here's where the merge conflict comes in. We are both editing about.html in separate merge requests. So if I do about.html, I'm going to say, hello, about us. Why am I adding this? Because I can. And git status. So we added 2 pages. We're going to commit it, add some pages. And whoa, 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 whoa. Write it, push it. Push it, push it. Okay, there we go. So we created a separate branch and we just pushed 1 commit to that branch. Let me finish creating that merge request and we should be good to go. So we have 2 changes on this merge request. One of them is touching about HTML as well. So we will merge this guy into master. So we hit the merge button. If we go back to the master branch here, you can now see that about.html exists. Now, our other feature that also touched about.html, you will now see that the merge request cannot be merged because there are merge conflicts that must be resolved because our about page is conflicting with the master branch. So how do we fix that? Well, if you have merge conflicts that GitLab is detecting, you're going to have to go in there and fix them yourself. So start by checking out the master branch and do a git pull so that you have the latest code locally for master because we're trying to merge into master, right? Now go check out your branch, which in this case is 2- issue number 2. And now we can say git merge master. So since we have number 2 checked out, the second branch checked out, and we say git merge master, it's going to take master and merge it into our branch. Usually auto merge would work, but in this case we created a merge conflict by both editing about, and it says conflict, merge conflict in about.html. So if we vi about.html, actually let's open this in VS Code so you can see exactly how it looks. Okay, much better, right? So VS Code actually shows us exactly the regions where the conflict occurs, and it all comes down to you can merge this however you want. You have to use your brain, your human brain, because Git couldn't do it automatically. Figure out how you want to merge these. You could completely discard your changes, you could completely discard their changes, the master in this case, or you can combine them in some way that makes sense, and this can vary depending on what it is. In this case it's just text, and I'm just gonna paste it in down here, but we don't need to say hello twice, so I'll just say about us, and then we can just delete these equal signs and all that, or you can say, you can use these accept buttons or whatever, but really it's just going to delete this text for you. So I deleted that, and make sure you get the bottom part too. Okay, we don't have any merge text on this page anymore. We're pretty much done. Now what do? We say git status, git add all, and we'll see our about changes, and we'll do git commit just like normal. But you'll notice that it pre-populates the message for us, which is good because it knows that we're doing the merge and we hit some conflicts. And make sure that all you're doing, don't add code, new code to a merge conflict commit. If you get a merge conflict, fix it, commit it, and then you can keep, go back to what you're doing. But all that said, we did our merge. Now we have to push again, git push, and we'll go back and look at our merge request, and we should see another commit. And you can see our merge commit that we just did, it has been pushed. And our changes are exactly these. We're in good shape here. We're pretty much done. We can approve it. All we have to do really is mark it as ready, hit merge, and we are pretty much done. Merged. Go back to master here, check out about.html, and it looks exactly like we wanted it to. So that's it. That is the flow for GitLab. GitHub has a similar flow, but the big point is people work on different branches. they code different things. Sometimes you have merge conflicts. Either way, you resolve the merge conflicts. You want everything to get merged into master. All the good code that you think you're accepting as the reviewer, as the owner of the software product, you're getting it into master, and that's really it. So this method of writing software in groups allows you to develop large projects. And if you're a new coder, you will probably be joining a team who uses something like this for their process for developing software. So with that said, I hope this was helpful. Thank you for watching. Please subscribe or like, I guess. And that's it. Thanks for watching. If you enjoyed, consider subscribing, liking, and joining the PageKey Tech Discord.